Okay, so there's a different type of analog digital converter technique. Okay, so they have a successive approximation, flash type, sigma delta, and dual slope. So however, most of the analog digital converter are using successive approximation. Okay. So when you come to why successive approximation is used, because it's balanced between the speed as well as accuracy. So if you think that successive approximation is not suitable for you, you can always purchase an external analog digital converter for your application. Okay. Here are the comparison. So again, SAR is always in the middle. So if you are dealing with analog digital converter, a certain mathematical calculations you need to understand. Like for example, if you're using 10B of ADC, and the V reference is between 1 volt and 4 watt. So sometimes you need to find out what is the conversion result if your ADC give you 500. Therefore, a bit of calculation need to be performed. Okay, so this type of calculation is very, very important, because most of the time, if you are a good designer, you're not putting in a formula. However, you're putting in the answer. I mean that you build your own lookup table. So it means there's a lot of memory will be used up for your, in your design. But however, you pack all these value into the flash memory, is not into the RAM. Okay, we will come to this later, no worry. So, and in a situations you have a problem of a small value from the analog, from the sensors. Example, the output from a sensor is from negative 10 milliwatt to 10 milliwatt. Example, negative 10 milliwatt to 10 milliwatt. Example, like here, 200 milliwatt to 300 milliwatt. So in order to achieve a better accuracy, normally we try to shift this. So to shift from negative 20 milliwatt to 0 watt, 500 milliwatt to 3.3 watt. Okay, in this situation, we need a voltage scaler and voltage shifting circuit. And class, remember, so you only need this circuit if necessary. If you think that the range given in the microcontroller is enough, so you can always ignore this. Okay, so that's the reason you always choose a correct sensor. Some sensor, they already built in a voltage shifting circuit. Okay, some sensor also built in amplifier to give you appropriate range of output voltages. Okay, so here are some of the analog calculations. So in the end, you just need to estimate the correct value of the resistor if you want to build a level shifting circuit. Basically, in this design, we are using 2 op-amp. Okay, so class, of course, I'm not going details in op-amp. I believe that most of you already quite good, in op-amp, as you learned in the analog circuit design. Okay, under Dr. Jun Boon. Okay, let's move on. Okay, here are some of the example. Please go through it, how to calculate the correct R1 and R2. So in the end, is basically we just do a trial and error. Same with the shifting circuit, voltage shifting circuit. Okay, so by using trial and error, okay, we can get a correct resistance value. Okay, let's move on. And here are some of the calculation you also need to know. Okay, from ADC, analog digital converter, or digital analog converter. So for example, if my V reference is 5 volt, okay, if my V reference is 5 volt, okay, and we are using 10 bit of ADC, so 10 bit is 2 power 10 minus 1, correct? These are all the range. Okay, what is the value? What is the output value if the output of the analog digital converter is 0x128? So basically, if the output from the ADC is this, okay, and you're using this is, so what are the, basically we are just using 10 bit. So what is the output, in voltage, the equivalent output in voltage? So based on the calculations, it's a 1.46 volt. Okay, it's same with the digital analog converter. Okay, so if reference is 5 volt, if you are using 8 bit, okay, and it's give you 0x-A9. So what is the output voltage? So the output voltage is about 3.3 volt here. Okay, okay. So similarly with here, if the V reference is 4 volt and the 8-bit ADC input voltage is 2.35 volt, what is the ADC output? So based on the simple mathematics, we know that the output is about 150 in digital value. Okay, so you have to convert this into the digital value. Okay, so let's move on. So again, in a lot of situations, we need sample and hold. Of course, when we need sample and hold on depends on what is the input. So if the input is a continuous signal and the input coming in very fast, so until the microcontroller do not have enough time to process this, at that time sample and hold is very important. So basically sample and hold just consists a capacitor. Okay, so it hold the signal and perform the appropriate conversion. Okay, so no worry, sample and hold is already built into most of the microcontroller that come with the analog digital converter. Okay, so these are the ADC block diagram for PIC24. So remember, PIC24 consists of 12 channel. So 12 channel means that basically you can connect to 12 different sensors and let it run at one time. Okay, so due to you're able to connect to 12 different type of sensor and perform analog digital converter. So therefore, we need an appropriate buffer. So basically, they got about 16 buffer. Okay, so the buffer is to store the result of the analog digital converter. Okay, we have a sample and hold circuit here. So basically, let's say you got a temperature sensor here, humidity sensor here. So once this thing is coming in, okay, you perform this technique is a SAR, correct? 10-bit SAR. So everything is being converted to digital and stored into the buffer, okay, and to be processed later. Okay, is it all right? So we go through this diagram in details. Okay, first of all, let's look at this VR select. So VR select, so for your information, analog ADC for PIC24 allow you to select or choose the V reference externally or internally. Okay, they are both got their advantages and disadvantages. Okay, if you're using PIC24 FJ64GA002, the input output pin just 28 pins. Okay, so as I told you before, input output pin is very important. Why? Because just 28 pin. If we are using external V reference plus and V reference minus, we already sacrifice 2 input output pin because they are shared. Okay, example. So if you look at the data sheets, V reference are shared for AN0 and AN1. Okay, so if let's say, for example, in one situation, you think that, oh, I just measure between 0 to 1 volt because my sensor only able to measure 0 to 1 volt. So I can connect this to 0 volt, connect this to 1 volt, V reference plus to 1 volt, V reference minus to 0 volt, example, okay? Or V reference to negative 1 volt, or V reference plus is 1 volt, okay? So it means you're already utilizing these 2 reference pin, so it means you already sacrifice AN0 and AN1. It just check how many how many input output pin you got, like RA0, RA1, RB0, RB1 is all other input output pin. So if you are utilizing these 2, means you already sacrifice these 2 input output pin. Okay, so in a lot of situations, if accuracy is not your consideration, it's not your concern, you can always using the V reference as a VDD and VSS, means your reference will become 0 to 3.3 volt because your by default is your input is 3.3 volt and 0, correct? This is your VDD value. Okay, let's move on. Okay, let's look at some of the general information of PIC24. So PIC24 is using SAR, successive approximation, and it's a 10-bit resolution, so it's 2 power 10. It's 2 power 10 means it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, means 1, 0, 2, 3. Okay, so they got multiple input. Okay, so clock source of ADC is either divided by FOSC or using an internal generated clock. So if you are using the internal generated clock, as for your information, if you are using internal FRC, it's 8 megahertz. Okay, so an 8 megahertz divided by 2 is a 4 megahertz. So this is a FCYC. And class, please reminder that TAD and TCYC are 2 different things. Okay, so TAD actually is an analog digital converter clock period. Okay, remember, for different version of PIC24 microcontroller, the conversion clock might be different. Okay, so if I'm not mistaken, for PIC24 HJ high speed is about 76. So for PIC24 FJ, okay, let's say I don't know. So you have to refer to the data sheet. What are the minimum TAD clock? Okay, actually, is it important to know this TAD clock? Yes, it's important. Okay, let's move to the data sheets. Okay, so towards the end of the data sheets, we have something called electrical characteristics. Let's go to the electric characteristics here. And under the section of electric characteristics, they should mention what are the minimum value for the TAD. Where is it? Okay, let's say TAD. So in this case, for the PIC24 FJ-GS004 family, so the TAD is, the minimum for TAD is about 133 nanosecond. This is the minimum. Okay, this is a minimum for the TAD. Okay, so and again, so for information, they got a lot of terms used in analog digital conversions, like sampling time, conversion time. Okay, so like conversion time is something that it cannot be changed because it's already pre-designed, in the microcontroller. Again, according to what I found, from the data sheet, the conversion time for PIC24 family is about 12 TAD. So here is the proof. Okay, you can open up. Where is my PIC24 just now? You can open up. I call that. You can open up the PIC24 analog digital converter, the details analysis. This one. Okay, I believe most of you, I already give it to you. Okay, class, if you think that the present data sheets do not give you enough information, you can always download the more details guideline, more details document files from a microchip. Okay, so in order to understand more detail of PIC24, okay, 10-bit analog digital converter. So I download this, and after I go through this in details, I found that according to one of the section, he said that here, he said that I cannot click. An ADC conversion requires ADC clock to convert each bit of the result plus 2 additional clock cycles, a total of 12 TAD for 10-bit conversion. So this means that you need about 12 TAD to perform a conversion. So this one you cannot change, it's fixed. Okay. However, the sampling time, all these things, is depend on your application. Still remember I told you that if the input is a continuous signal, so your sampling time should be 2 times. The sampling time should be 2 times of the modulating signal. So according to the Nyquist rate. Okay, so again, rule of thumb, you shouldn't have too many samples as well. If you have too many samples, you're wasting your CPU power, because we try to save battery, isn't it? Right or not? We try to save the energy used by the microcontroller. So again, the sampling time is depend on you yourself. Okay, but however, the TAD time is fixed. I mean, not the TAD time, the TAD for the conversion rate is fixed for 12 TAD. Okay, so but the minimum time for TAD is 133 nanosecond for PIC24 FJ. If I'm not mistaken, that time I put 76 is for HJ, high speed. Okay, so it's depend, you know, again, you have to look at the respective data sheet for more information. Okay, so I put the red color here, 13 TAD. So it, again, is depends what is happening, you know, in your design. So that's why this you can just cross it. The red color you can cross it. Okay. So you see, for 10, I just cross it. So why? Because different microcontroller have different, you know, conversion time, you know, different sample and hold time. For PIC24, fixed, we can prove it such that the conversion time is about 12 TAD. Remember, TAD is not the crystal clock frequency. Okay, it's a ADC clock period. Okay, let's move on. So for information, there's a lot of special function register for analog digital converter. Okay, let's go through it one by one. Okay, so I believe most of you having difficulty, you know, to choosing the right value for your special function register. Okay, let's begin with this. As I told you just now, okay, so the V reference for an ADC for PIC24, we can choose externally, you can choose internally. So based on this special function register ACON2. Okay, let's say, for example, my VDD is I want to choose both internally, then it's a 3.3 volt and 0 volt. Okay, like for example, I just want to choose 1 volt. I want to utilize one of the port, and this is 0 ground 0. So it's perfectly all right. So in this case, we just sacrifice one input output port. Okay, again, it depends on your sensor. Is it needed to have such high accuracy? Okay, so okay, let's move on. So however, we have another few special function register. We got ACON2. In the ACON2, we got a very special pin called CSNA. The CSNA is just to decide, you know, whether you are choosing the channel or you choosing the SSL. Okay, they got two options for you, channel and SSL. No worry, we look at it in details later. So in SSL, they give you about 0 to 15, means they got 15 input, correct? 16 input, correct? AN0 to AN15. Same with the channel. We got B and A. Okay, so basically B and A is where we are perform a multiplexing. Let's say you got 12 channel here. Sorry, they got 12 channel here. Okay, and you think that you need to get the data in every 20 millisecond or 500 millisecond. I'm not sure. So that's why, you know, you keep on multiplexing. You can multiplexing to store all this information into the your buffer to perform the analog digital converter. So it's up to your application. Let's say because you fully utilize all 12 channel. Okay, so you want to do a multiplexing, you know, for the system to do conversion, you're allowed to do this. Okay, so in your situation, at most you just use 2 analog digital conversion channel. Okay, you're not going to connect 12 or 13 here. Is it AN0 to AN12 is 13 channels, correct or not? Okay, so and of course means if you got 13 only, we're not utilizing these two we're not utilizing, we just use up to A0 until 12 so we don't use this is 1K. Okay, because some other microcontroller like 128 pin, probably they can support until more than 12 channel. For PIC24 FJ, the one we are using, the maximum is just about 13 channel. Okay, 13 channel. Okay, so if in your case you just don't care these few things. If you're using multiplexing, this all will become a don't care. And please reminder that please convert everything to digital mode if you are doing digital input output, and please convert to the analog mode if you're performing analog input. Okay, and by default everything is in the analog mode. Okay, now here is an example of doing a channel scanning. Okay, So CSNA here is to determine whether using a channel or the scanning channel. Scanning channel means that I'm choosing, let's say in this case, I'm connecting AN14, one channel, one sensor, AN13, another sensor, AN2, another sensor, AN0, another sensor. Okay, class, for the high-end PIC24, they can support until 16 channel. Okay, for our PIC24, because the pin is limited, they can support until 13 channels only. Okay, others can support until 16 channel. So let's say I connect these to 4 different sensor. Okay, so basically I can I choosing external V reference. Okay, so then I can start doing whenever I start the conversion. Basically all the result will be stored into your buffer. Okay, you're allowed to choose such that is it each conversion means each data that coming in successfully being converted, they will start an interrupt, to tell the microcontroller, hey, I'm counting already, my channel 1 is converted. Or you're allowed to select, okay, after four channels, 4 result is being converted, then you activate the interrupt by activating the sample and convert interrupt selection pins, okay, at the ACON1 register. So this means that if I put 1, 1, 1, 1, 1, 1, so this means that I ensure all 16 buffer is being converted, then I will start interrupt the microcontroller, tell, oh, I got done already, like 16 channel sensors, the input is already being converted, okay, to digital value. So it's up to you. But if you're using only one channel, just put 1 0, 0, 0 lah. If you're using only one for your case example, for your assignment, you only use 1 buffer, correct or not? Are you using connect to a lot of sensor? If no, just 1 enough. Why you want to wait until 16? If wait until 16, all give you a same value. Let's say I connect this A15 to my variable resistor. After you convert, let's say this is 0, 0, 0, 0, 0, 1. All will give you the same value. Okay, so this is what I did in my lab section. In the lab section, remember I give you one lab for you to try out. Okay, so I'm using 16 channel. So all the buffer is coming out. We give you the same value. If you don't believe me, if you run in the Proteus, you can open up the ADC buffer and check what is the content of that buffer. Okay, so is it all right? Okay, so let's move on. And class, even though you're using MPLAB X, you also can perform a debugging. How? By putting in any value, by just selecting any input value. Okay, in our notes, over here in our where is it? In our assignment, okay, we are using a variable resistor. Yes, it might change, different value will come in, correct? You can make assumption any value that's stored in the buffer, okay, so that we can see the output is correct or not, because we are not able to touch the input, correct? And moreover, MPLAB X also give you sections, in the stimulus to put in analog value. Okay, you can check and have a look, but of course it's still the best you hook into the Proteus. Okay, so we'll have a look after this. Okay, so again we have other things like alternate. Alternate means your multiplex between A and B. Okay, let's say for example you got two, you are fully utilizing the multiplexing A and multiplexing B. Okay, so it's up to what you want to do, in your design, in your application. So like ASAM is to sampling start immediately after the last conversion. Okay, so sampling begin when sampling bit is set. So normally I will set to 0 normally I will set to it depend what is your application. From my side, I will always set everything automatically. Okay, like for example SAMP, sampling and hold, amplifier start sampling and hold is start holding. So okay, so it depends what application you want the system to do. But for me, I don't care about all this, okay, because I don't do the sampling whole if your input is not continuous signal, okay, especially if you are connected to the temperature sensor, unless the input signal is a continuous signal like voice, okay. So again, we have a lot of types of conversion. So basically, I just choose auto convert, unless you got other techniques to do the conversion. Okay, conversion trigger source select bit. I will do auto convert. I let the internal counter to do all this job. Okay, is it all right? So unless you got other way, you know, you got timer, you can activate the timer to do the conversion, the speed of conversion, how the speed we can control by timer tree and so on. Okay, but however, I always choose one moment. Let the internal doing all these things. Again, it depends on your application whether you need all this or not. And then you got a sampling. This one you are not recommended to put 0 lah. Your sampling rate is 0 immediately no ma, correct? You can put this, okay. It's not wrong, but it said not recommended. Okay, so it just it depends. I always choose in the middle. Just if you don't know how often to be sampled, okay, especially for discrete signal. If a discrete signal means this, you know, let's say your temperature sensor is fixed, okay. So what is the sampling rate? Okay, so if a continuous signal, you need to do a bit of calculation. Make sure that the Nyquist rate is a byte. The Nyquist rules law is a byte. Okay, so it's a 2 times of the sampling frequency, modulating frequency. Okay, so ADCS is the where you need to do a bit of calculation. We look into this later. Okay, so class, remember if you're using 24 FJ, okay, you are not performing a simultaneously conversion sampling. So if you are using some high-speed microcontroller edge version like I told you just now, you can doing a simultaneously sampling lah. Okay, so but in your case now is not necessary. But please reminded, choosing a right analog digital converter is very important according to your application. Okay, so here are some of the example. Okay, before I look at the example, let's look at the final slide first. Let's say look at this, how to calculate ADCS. So this formula is given, okay, in the data sheets. Okay, so please look at this. Please look at this slide carefully. So in this slide, he said that assume 20 TAD for sampling time. So my sampling time, just write out all the information. My sampling time is 20 TAD. Okay, and you also know that the conversion time is fixed, is 12 TAD. Okay, you can't change this. All right, 12 TAD is fixed. So he said, assume that 20 TAD for sampling time and the internal FRC is used. So if internal FRC is used, your FCYC is 1/4 megahertz. 8 divided by 2 so it's about 0.25 microsecond. Okay, so what is the value for ADCON 3 if 10 samples are collected in 0.8 millisecond? Now, you see class, 10 samples are collected in 0.8 millisecond is given by the application. You know what is application, you know the sensor give you an output, you know that you need to collect 10 samples in 0.8 millisecond. If you're not able to collect 10 samples in 0.8 millisecond, disaster, might be some disaster might occur or be inaccuracy might occur. So that's why you need to follow, the requirements given to you. Okay, or let's say you're doing a variable resistor, you ask yourself, is it I need to collect this how many samples in this time? Okay, so is it necessary? Is it important in your case? Okay, please ask this question. So for here, he said 10 sample in 0.8 millisecond. So this means what? So this means that the sampling time 20 TAD plus 12 TAD. This is for 10 . is equivalent to 0.8 millisecond. I want to get for one sample, correct? Divided by 10. So so in the end, 32 TAD is equivalent to 0.08 millisecond. So what is my TAD? Is 0.08 divided by 32. 104. So this is equivalent to 0. How many zero? Millisecond. 0.025 millisecond. So this is about 1 to 25 microsecond. Am I right? It's about 25 microsecond. So therefore my ADCS is equivalent to 25 divided by 0.25 minus 1. So it's 10 minus 1 equal to 9. Okay, so that is my value in the ADCS. So but now what is the value in ECON tree? So let's look at the data sheets, okay, and look for the special function register ECON tree. Okay, where is my data sheet? This one is it? So ECON tree. So ECON tree basically is this. So first, are you using internal clock? So if you are using is it ECON tree correct? Yes, ECON tree. So ask yourself, clock derived from system clock and ADC internal RC clock. We are not using RC clock. Okay, we are using clock derived from the system clock. So that's the reason this should be 0. This is RC, you know, internal RC, not RC. We're using the system clock, 0. So then the sampling time. What is the sampling time? Just now is 20. So this means that here should be 20. Okay, here should be 20. So it should be 1 0 1 0 0 1 2 4 8 16 16 plus 4 20 lah. 16 plus 4 ma. Yeah, 16 plus 4 is 20 lah. Okay, so the ADCS here we calculate just now is what value? What is the value just now? 9, correct? So basically it should be 0 0 0 0 1 0 0 1. Okay, so this is 9. So what is the value for ECON tree? So the ECON tree should be 9 0 4 1. So it should be 0x 1409 for the ECON tree. So is it okay so far? So any questions from the floor? Okay, actually to perform this kind of setting is not difficult. And you say, oh, there's so many special function register. Basically, it just refer to the data sheet and configure it accordingly. Okay, let's go back to our notes. Okay, so since we already have all these things, let's start with an example. Okay, let's say in this example, let's start with an example. Okay. So in this example, you know, it's just so exactly like what you did for your assignment 1. Let's say we have a variable resistor. We got a variable resistor here. Okay, want to do some conversion into the port RB2 or AN2. So same, we define our input output voltage. Okay, so then all the settings. So this setting is based on like turn on, auto sampling, auto convert. Okay, so basically it depends on your application. Then based on your applications, then you change all these special function register accordingly. Like for example, ECON on, it just activate the analog digital converter. Okay, means on means it start converting whenever they receive any input output port. Okay, so this one, discontinue module when enter idle mode, continue module operation idle mode. It's up to you. You want your system can do analog digital conversion process during the idle mode or not. So I don't know. So basically it's up to you, correct? Based on your own application. So then the output format, is there output format? It's just an integer, or do you have a sign after your conversion? Normally we just put integer. Okay, and it's up to you. Class is up to you. Then you always choose auto convert, as I told you just now. Okay, so sampling begin immediately after the sampling bit is auto set. Okay, so normally I will always say sampling begin when sampling bit is set. Okay, so normally I don't choose this. I don't set the sampling bit. I always choose the one sampling begin immediately after conversion is complete. All right. Okay. So again, whether you choose which one is up to your application. Whether the input is a continuous signal or not. Is it important how your sampling time or holding time, is it important for you? Okay, so then this one means done when analog digital converter successfully completed. Automatically this will set to 1. Okay, but you need to clear it. Okay, whenever the ADC successfully converted, so this will set to 1. So if you're using interrupt, this will cause an interrupt. Okay, this will cause an interrupt. If you don't use interrupt, use pooling, you keep checking this pin. Is it done? Is it done? Is it done? Okay, while not done, you keep on continue. When done, then only you exit. Okay, is it all right? Let's come back to this example. Okay, where is it? Okay, so see now, you see this pin? While not done, I do nothing. He's using pooling. He's not using interrupt. So you go, wait, done. After done, the output voltage in digital, you take out from the buffer because it's only using one buffer, only one buffer. Okay. Okay. So let's look at Aircon 2. So Aircon 2 basically is check whether what you are doing, what setting you are looking. Configure for V reference or V plus. Let's have a look of the data sheet for Aircon 2. Actually, it's quite straightforward. So again, do you perform scanning input? If you got multiple channel, in multiplexer A, then you do a scanning input. Now you don't need. Okay, so and then this is not implemented, and of course this tree is for you. These 3 bits is for you to choose whether it's external reference or internal reference or vice versa. Okay. So buffer fill status. So remember we got 16-bit. The buffer got 16-bit. You fill up the upper bit first or lower bit first. So again, it's up to you. Okay, what to be filled up first? Normally I would choose 0 lah. Okay, filling up and then should access 0x. So how this thing is being accessed, how this thing is being read. Okay, so and then this is a sampling time, sample and convert time. So normally I will pick 1 if you got only one channel or one buffer. Okay, so same with this. Your configure 2 8-word buffer, mean your buffer can split into 2. Means your buffer can be split into 2 or 1 16-bit by itself. Mean buffer you can split into 2 one by one. Do you just need 8-bit? Or you want 1 16-bit, the whole things, after it's converted. Okay, class, although it's a 16-bit, remember we are using 10-bit of conversion only. So then alternate, is it always using A multiplication or using a multiplexing for A and B? Of course, we don't use multiplexer B, correct? We're using A in our situation. Okay, class basically is very straightforward, same. The Aircon 3 is based on your requirement. I will show you just now. And this one is your channel. Okay, this channel. So which channel you're choosing? So normally we are the negative input is not this one, not this one. We are choosing this. Okay, and then which channel you are using. If you're using channel B, if you're in channel 1, which channel you're using. So in our case here, we are just using channel A. Okay, we are just choosing channel A. So that's a reason. The AD1 CHS is ADC voltage. The ACT voltage is 2. Means it's RB2 lah, channel 2. Not RB2 means now we're using channel 2. Okay, RB2. Okay. Okay. So and so on. Disable the digital input and then no scanning. We are not scanning, correct? We are not scanning. Okay, no scanning, So remember, this is scanning is we have a multiple input here. Let's say for example 1 2 3 4, you means you keep on scan, keep on getting the result, or one get this, then coming back again, keep on getting this. Okay, while the analog digital converter doing conversion, you take out the data. This one keep on coming in and fill up your buffer. Okay, is it all right? Okay, so all these things is just set accordingly according to your applications. Okay, if you prefer to use interrupt, this is how you perform an interrupt. Okay, so these are the fixed reserve word ADC interrupt. So here you can put no auto PSC here is the same. So you just configure accordingly. So when interrupt occur, they clear the interrupt, the analog digital converter interrupt flag and perform. How you write the interrupt service routine is up to you. Okay. So of course you need to enable all the interrupt accordingly lah. Okay. This one is to enable the analog digital converter interrupt. This one is to turn on the analog digital converter. When your DONE is set to 1, automatically he jump inside here. Automatically he cause the AD1IF become to 1. Okay, so it's up to you how you want to do your work, whether you want to use interrupt or you want to do pulling. So it's up to you again. Okay, here is some of the another example is exactly the same. You can go through it by yourself. Okay, so until now, any questions from the floor? Yes, am I going too fast? If no question, give me a thumbs up and please ask question. Yes, why so quiet? Or you already lost in the jungle? Yes, is it okay so far? Why no action? Or you are all not here actually? Yes, if no response, I'm not continue. Any question from the floor? Why so quiet? I'm so scared, you know. Okay, at least got some response now. Okay, very good. Okay, so okay, let's move on. Okay, I like the cute penguin just now. Okay, so let's start with the temperature sensor. Let's move on up. So temperature sensor, you see those days, your senior are using LM35. Okay, this is the one in the lab. And class, please remember, a lot of students burn this, but of course now you don't, what I call that? You don't use temperature sense. I mean, you don't use the hardware type of temperature sensor. You're not using LM35 or LM34, okay? But you just use it in Proteus for simulation purpose for your main assignment, okay? If you're using ESP32, you're using DHT11, okay? Because DHT11 got both humidity sensor and temperature sensor. Do you know why I don't ask my student to use DHT11 in PIC 24? Because the student keep complaining because they don't know how to look at the timing diagram. Okay, but I hope this round you guys able to read the timing diagram. Just class for information, LM34 is very straightforward. Very straightforward. You just connect to. Just got 3 pin. It's just like an what I call it, like a transistor. No, it's just like something like this. 3 pin. Okay. And the problem why your senior keep burning my LM34 and 35 because of the data sheets. Okay. Let's have a look of the data sheet. I'm not sure whether I still is not here in lecture 2019. Let's look at LM35. Okay. Hey, not this one. Hold on. LM34. Yeah. Class. Do you see this? And why a student keep burning this beautiful LM35? Because of this word. When they see like this, they can't differentiate which one is positive VCC and which one is ground. He said bottom view. Is top view is the other way around. So students keep burning now. They're burning, they're so happy. Smoke come out. Oh yeah, okay, burn. Then they return it back and repeat the process for many times. Then only you know that, oh dear, is this word. But are you sure you, when you look at data sheet, you read all these tiny, small things like this, all these are. Okay, so it's very important. Please keep this in your mind, or else you're killing a lot of people. Okay, all these things. Okay, so this is very important. Don't ignore all these tiny words. Okay, so let's move back to our lecture. So again, advice for all of you, please, look at your data sheet carefully, or else you keep burning your beautiful devices. Okay, let's say LM35 normally is ranging from 0 milliwatt to 10 milliwatt. If you don't connect to negative value from a V out, if you connect to a negative V out, you already enable the capability of measuring negative current, negative temperature. So for example, I can measure from negative 55 to 150 Celsius for LM35. Whereas for same with the LM34 is measuring in Fahrenheit, and this measure in Celsius. So you can do the conversion in your program. Okay. So remember, if you connect with a negative voltage source to the V out, you already enable the capability to measure the negative Celsius, negative temperature. Okay. So whereas if you don't have a chance to play with what I call that negative temperature, then you just put it 0 to 10 milliwatt. Okay, just 0 to 10 milliwatt. So class, please, be smart, when you're doing this kind of design. Let's say this is 0 Celsius until, let's say, example, my 0 Celsius until maximum 150 Celsius. You're not going to directly convert it to become 0, 0, 0, 0, 0. This will become 1, 1, 1, 1, 1, 1, 1, means 0 volt, 3.3 volt. Am I right? So this is not a good design. Why? Are you sure in your application you need to measure negative 50 Celsius, negative 150 Celsius? So hot. If this is applied in the farm, your farm is melted already, correct or not? So you ask yourself, what is the correct output, if this is applied in your farm? A farm is normally minimum 15 Celsius is already very good already. You don't tell me you can reach 10 Celsius, everything will die in your farm, all the animals will die. So it's until in Malaysia, maximum I don't think so can reach 37 Celsius, correct? Crazy. Malaysia, I think it's 35. I don't know, indoor, all this aircon. So that's why you want accuracy, you have to try to reduce the range. Okay, so this you mark it to become 0, 0, 0, 0, 0 or 0 volt. This is actually 3.3 volt or something like that. This is how you increase the accuracy of your design. Okay, let's move on. Okay, so let's assume that in this design, I'm using LM34. I'm measuring negative 50 Fahrenheit, 120 Fahrenheit. Okay, let's assume that we are using peak 18. Okay, is 0 to 5 volt. Example. So this means that negative 50 Fahrenheit will come out, will give you how many, what is the value in milliwatt? 500 milliwatt. Whereas for 120 Fahrenheit, let's put it Celsius. Fahrenheit is so small. Let's Celsius. It's Celsius. So LM34 is Celsius or what? Let's LM35. I like Celsius. I don't like Fahrenheit one. Okay, let's Celsius. 120 Celsius will give you about 1.2 volt. Am I right? So ask yourself, do we need a signal conditioning circuit? Do we need to do amplification? do we need to do a level shifting circuit? Or I can directly change my re-reference, okay, to negative 500, means negative 0.5 volt. So it's up to you whether you think that is necessary or not. Okay, is it necessary or not? Whether you play with this, okay, you play with this. If you, it's up to you. Okay, so then, okay, so this circuit means able to display all these sources, you know, into the LCD or into a 7-segment display. Okay, again, choosing between LCD and 7-segment display also an art. Why? LCD, you can't see clearly in the bright sunlight. LED, which is a 7-segment, actually is each segment is an LED. You can see things clearly, you know, in the bright daylight. It's just like the display board along the highway. That one is not LCD, it's LED. Unless you're using a super bright LCD, I'm not so sure that it's very high in power consumption. Okay, let's have a look over here. Okay, so in order to have an accurate calculations, okay, as you know that if I got negative 50 Celsius, okay, I will have about, let's assume it's 8 bit lah. 10 bit is very difficult to calculate lah. I mean, not difficult lah, I mean very difficult to show you. Then you ask why divide by this. Okay. So this means that when my analog digital converter see this value, I know that is a negative 50 Celsius. When my analog digital converter output, I see 1111 means it's already achieved 120 Celsius. Okay, so then this means you need to build a formula. A lot of students build a formula. He said that, oh, the temperature is equivalent to the digital input, digital output value multiplied by 170. 120 plus 50 is 170 maximum value 8 bit is 255 2 power 8 is 2 power 8 minus 1 okay, minus 50. All right so if the digital input is 11111111, then cancel off this will give you what give you 120 Celsius okay. If the digital input is all 0, give you, if the digital output input is 0, then you give you negative 50 Celsius okay. Let's say if the digital output is 0000, digital output is 00000001. Okay, what is the temperature? Okay, it's become 1 multiplied by 170 to 255 minus 50. You calculate, I don't know what is this value. It should be some value should be negative what okay, based on, let me calculate it, 170, okay, 49.3 Celsius. Okay, so this is what you want to display on the LCD. This is what you want to display on the LED. Okay, if you're using LCD, you think LED. So a lot of students, okay, I didn't say it's wrong. He purposely in their program, they just they build the formula 170255 minus 50. This is a ADC 1 buffer, correct? Output, correct? Okay, class, I didn't say this is no good. So, but you must remember that most of the microcontrollers do not come with math processor. When you perform this mathematical calculation, let's say in C programming, you consume a lot of your processing power. Okay, and probably, you know, is you get burdened, you know, to your microcontroller. So rule of thumb is you build your own lookup table. So this means that you need to build a lookup table from 0000 until 11111111. Okay, that's the reason in those days, microcontroller, a lot of time they build their own lookup table. Okay, and of course, this lookup table, all these things are not stored in the RAM stored in the flash memory by using what? Using the constant. Right? Not like example, I can say, let's say this is 8-bit. I say temperature high. Okay. Let's assume that we are using 7 segment. I just simply draw let's say my microcontroller. Okay, I connect to 4 7 segment example or it can be LCD yeah. Okay, 4 Okay, so how should I do those days you learn under microprocessor, or I need a transistor to switch it on and off. Correct? I need a transistor, 4 transistor. Okay, NPN transistor. Correct? Okay, a resistor. Yeah. Okay, and probably I can doing a 744 a decoder, up to you a decoder 74 LS 244 example. Connect all the pin to all the segment How many segment 1 2 3 4 5 6 7 8 don't know, 1 2 3 4 5 6 7 8. Okay, connect over here. This one is determined to lit up which LED, whether using a common cathode or common anode. Okay, so glass is quite similar to LCD. LCD is more straightforward. I will teach you in future. Okay, so 7 segment also is very important. Still remember, those display board, all these things are LED. This is all LED to light LED. Then I can build my table. Let's say, for example, I know that I want to display 49.1 just now. 49.3. Okay, remember when you come to 49.3. Okay, so 4 is the position over here to light up the 4. And then I don't know how you decode these things. So you can have a temperature high, temperature low. Okay, let's say don't say how do I do it. Okay, my display pattern. Okay, so this is all my display pattern. Let's say 0x 74 is display negative. 0x 30 is display 0. Example like this. So that's here I can put all my possible output to my possible output, for my analog digital converter. So let's say, for example, I can say 0x let's say okay, let's say A 50 degrees Celsius, 49.3. Okay, so A. So sorry, this should be 0. This is display 1. So the final value 10 A position number A is a negative value, mean negative here. A, B, C, D, E, F. Okay, I don't know what's the value. So by calling this, I can point to the respective position and passing this information and display into my 7 segment. I hope that you got what I mean or not. So normally we're doing this lookup table, but a lot of students prefer this No need. We have lookup table so mafan. Have to work 2 power 8 means 256 times. 2 power 10 means 1024 times. So you can using Microsoft Excel and copy and paste. Let they do the work. Copy and paste all the result into the lookup table. It's up to you. But remember, if you are the professional designer, you are looking for a proper design. So you will using this rather than this. If you're using this, is power consumption is very high. You also take up a lot of memories. I mean, because it's a lot of calculation is going on. Okay, so again, this is not very recommended. People will prefer using lookup table. Okay, so of course, they got other type of temperature sensor. This is a temperature sensor I introduced, okay, for ESP32. So the connection is very easy. They got 2 types. Some student like DHT to 22, more expensive, cheaper, but I still prefer this. It depends on you lah. So what is the advantage of this based on here? First is the sampling rate lah. This is 1 hertz there. Okay, this is just 0.5. This one looks smaller. Okay, looks smaller. So these two are one of the advantage of this thing. This. Okay. So they got pro and cons when you're choosing your beloved microcontroller. Do you know why 1 hertz? When 1 hertz means we are one reading every second. This is one reading every second. So this is one reading every 2 seconds. Every 2 seconds I read, every 1 second I read. Means the sampling rate this is higher but it just another problem. This one can have negative or this one no negative. This one up to 125 Celsius. This up to just 50 Celsius. Again problem. And the accuracy is not so good. Okay, this accuracy is just 0.5 different. So it's up to you. Okay, but for student, you want cheaper. Your accuracy is just for demo purpose only, and then you're not going to negative. Don't tell me that you're able to measure negative temperature, and don't tell me that you really can go up to 100 Celsius. What are you doing? Okay, this is more towards industry. Okay, but you, this only just need to feel the concept. Just feel the concept. Okay, but if you're using ESP32, okay, let's have a break. Let's have a break. Then you are okay. Let's have a break for a while. Okay, let's have a break. Okay, so I stop recording. Let's have a 5 minutes break. We come back in 1:15. Okay, so any questions? Where's? Oh, thank you very much. It's 49.3. I calculated it. Okay. So class, any question that you are not sure and you can ask now. You come back and 1:15. I'm here. Okay. So I hope that you grasp my concept of. Okay, I redraw all this thing nicely for you lah. It looks so ugly here. I will repose all this lah. I repose all this and then in different slide, so that it looks nicer, not so messy lah. Okay, I will teach you how to use LCD. No worry. 74244 actually is just a buffer, to give enough current to drive this 7 segment. Okay, or you can using a 7 segment decoder. Like 74244 is just a buffer, to sometimes my controller, I don't know lah. Let's say you got so many, they got 4 7 segment. My controller might not have enough current to drive this 4 7 segment. So that's the reason we need a buffer lah. The buffer have a very high fan out. Okay, or you can using a decoder lah. Decoder is PC 7 segment decoder also okay, also okay. Okay, this one is just to switch on and off transistor, just to switch on and off, which one to display first. And remember, even though it's on and off, our eyes couldn't differentiate because it's too fast. If your eyes are like a Superman eye, you can see this one being start first, this one start first. Okay, I hope you got what I mean. So any questions from the floor? No questions? Yeah, any questions? We still got 3 more minutes. Yeah, any questions? Yeah, Jing Hao. Any questions, Jing Hao? Well, Serene. Serene, any question? Or you join at 109? Is it I'm wrong or what? Serene, are you in? Is it okay? You only join 109, huh? So any questions so far? Now my is recorded lah. Okay, let's start. Return back. Let's start again. Okay, recording started. Okay, just now some student PM me. Yeah, got Shao Hong, got your Ji Shao Hong. Yeah, your big name is here. Yes, yeah. Okay. Like a class just now, somebody, I don't know why you want to secretly Facebook message me. Next time, just post it here, or probably he want to remain it secret. Now, just now they say, okay, class, in the first place, I repeat, you can use this formula. I didn't say no, you can use it. It's perfectly all right. So I mean that if you are in industry, sometime if you're using what I call that, a slow speed microcontroller, probably you can consider using store all these pattern, in an array. Okay, like for example, this one, why I got A5, why I put A5, because I already know that A is a position of the display pattern A. This A is position 10. Example only, position 10 is probably display negative. Display negative or for this LED 7 segment. 5 is position 5. This 5 is a display pattern for 5. Okay. If you don't want this, then you change the 74244. 74244 is just a buffer to give enough power, enough current to drive all these 7 segments. You can change this, to BCG 7 segment decoder. Okay. If you're using 7 segment decoder, you don't need to use all 8-bit 8 lines here, correct? You just use the 7 segment decoder. I think it's 4 lines only, correct? So it's up to you how you design your system. Okay, is it fair? Okay, so DHT11. Okay, class, when you come to DHT11, if you are using MPLAB, it's super easy. Why? Because the library is given to you, and actually you don't even need to care what is going on in the library. Okay, you call the function. You include the library, then it works. That's all. You just tell them which particular pin is connected to your ESP32. I think I got some example just now. I didn't. Okay, you got what I mean or not? So this DSG library is like this, you know. You have a look here. See, are you going to write this? All these are your library, you know. Actually, it's like this, you know. Yeah, the header file is like this, you know. Okay, but for you, you don't care. You just call the function. You just call the function. You just call the function. You just call the function and read out the value. You display the value onto the LCD. That's all. Okay. But if you are using PIC24, you have to write this library. Okay. So for me, it's important to understand how this library is being created. Okay, for student. For developer, we don't care. For student, it's important. You know why it's important? So if you're let's say PIC24 do not give you this facility. Okay, all the sensor that you have in this world are not necessarily got this library. But of course, thanks to Arduino compile all these things, you know, put everything in the GitHub, all these things, you know, we have a respective library you call, and then it will work as it is. Okay, so if you're using like what I call that? If you're using DHT11, there's DHT11. Let's say using DHT11, you need a data sheet. When you need a data sheet, you must understand all this timing diagram. Okay, like this. The connection is very easy. So, where's the? So you need to understand all this timing diagram. Okay, let's go back over here. I'm not going details over here lah. So in order for the microcontroller to functioning, I make sure that it's low for how long, then trigger up for how long. You see or not? Look at here, DHT response to microcontroller. You make sure that you low for 50 microsecond, up for 28 microsecond, then only you trigger, you know, to tell the DHT11 and your microcontroller can be start communicated. Okay, so this one you need the timing diagram is very important, just to let you know. You see, to start this on off, you know, this microcontroller signal to the DHT11. DHT11 had to respond, then only the data of temperature and the data of humidity will transfer to the microcontroller. Okay, so this is just what I want to let you know. Of course, now I'm not going details on this. Why? Because different sensor have different algorithm, different way of communicate to your microcontroller. But if you're using ESP32, you are very happy because a library is given to you. Just call the function. Okay. The only problem of ESP32 is which function to call. That is a big question mark. I see a lot of library, too many library until you don't know which function to call. How do I know that it's really calling this function? Okay. So at that time, you need the Google. Google is a best friend. Okay. So in the end, you must ask yourself, are you just make your system work on it without don't care what is happening in the background, or you want to learn how to write appropriate library? For information, in the market, not many people know how to write that particular library. A lot of people know how to use it. So this means that if you know how to write the driver or the related library, you are in demand in the market. Just for your information. Okay. So, and that's the reason you need to know how to look at the timing diagram. I will lead you slowly. Okay, so let's come back to this. Okay. Okay, of course, there are a lot of temperature sensor in the market. Okay, of course, and for the moment, I'm not going through in details. We come back to all these sensor later, because I want to kickstart real-time operating system, because this is what you're going to do in the next week. What I call that next week lab. Okay, I'm shifting lab 3 shifting between, I swap, between lab 3 and lab 2. Okay, and class, please reminded that in the final assessment, the question 1, you are asked to read the data sheets. Question 1 is a case study. Okay, so you must learn how to draw flow chart. You must learn how to write the specification like the one you did in your assignment 1, like user specification, system requirement, system specification. So okay, please try to understand all these. Okay, I will give you a case study. So if you refer to my past year question, and for your information, all my past year question is my tutorial question. So if you look at my past year question, you understand what is happening in the final assessment or in the final exam. Okay, let's move on to real-time operating system. Before we move on to the real-time operating system, any questions that you are not sure and would like to ask? Anything? If no question, just say no, type no. I want you, I need you guys to participate. Yeah, any questions, class? No. Okay, very good. Since no questions. Okay. Okay, great. Okay. Okay, great. Okay. So class, we start something that is very challenging. And class, please be reminded that computer science student take 1 semester to learn operating system. Okay. 3E and MH just take less than 2 weeks, to learn real-time operating system. Okay, well, fantastic. Okay, you can look at the teaching plan. Here, our teaching plan. Okay, I didn't lie to all of you. Let's look at the syllabus. You see, I'm starting real-time operating system here. It's a real-time operating system, real-time kernel, TCP/IP web server, everything in 6 hours. Wow. Okay, they say because this subject is an elective. Okay. Okay, so I also, it's impossible. Actually, it's impossible for me lah. But I can make it possible. I hope I can make it possible. So this means, class, listen very carefully. Real-time operating system can consider is a very boring chapters because it's a lot of definition. Okay, first thing. Secondly, and this round I included free RTOS. Okay, because due to you have ESP32. Okay, so there's more things inside. Okay, second. And the third thing, no worry, I will extract out only the importance. And if you think that other things that is also important, that which I didn't include it, so you have to play your part to read it, to explore it, to Google, go to Google. Google is your best friend. And for information in these sections, I give you a lot of notes and a lot of informations. Okay, lecture 4. I give you a lot of reference notes for free RTOS as well as new course 2. There's a lot of informations over here. Okay, so let's begin. So 3MH, those days when I'm teaching real-time operating systems, okay, I'm from FICT, computer engineering. I'm a lecturer down there those days. So, and FICT, we also got computer science students. So at that time, 3E, all these things, they say, oh, computer science, like all these database are low standard one, they don't care. So programming is not very important. So the answer is not true. You have to break the wall. So for 3E student, for MH student, programming is very, very important, especially real-time operating system, especially nowadays, everything is in IoT. Okay, when IoT coming in, real-time operating system is very important. Okay, so when you talk about Micro COS2, we refer to the founder, Jean Labrosse. If you talk about free RTOS, You have to look at the founder, Barry. His name is Barry. He's a founder. Okay, I will upload a lot of video later. The fighting, the interview between the founder of MicroCOS and the interview between the MicroCOS and the Barry, who is a founder of FreeRTOS. They will do a bit of debate, very interesting. So I hope you watch it. Okay, so let's begin. But what is operating system? So a lot of people, what is operating system, correct? So you are using your operating system. Okay, so operating system, basically, I'm using Windows 10, and students don't like all these Linux. Actually, they are better anyway, better in memory management. But due to Windows 10, the marketing team are very strong. That's why almost everyone are enjoying Windows 10. Okay, so basically, operating system is manage and synchronize the resources for application program. Okay, so the resources might be I'm having CPU, memory, display, keypad, mouse, all these things. My drawing pad. So it's run concurrently at one time. So basically, the operating system will manage all these things. So who manage all these things? There are one name. His name is called kernel. Okay, all the operating system, whether it's an operating system or real-time operating system, they got something called kernel. Okay, so kernel is the one who manage all this. Okay, but remember, the operating system that you have, consume more than 1 gig. All right, when you install, I'm not so sure. Windows 10 is about 1 gig. I don't know, 1 gig, 800 meg. Yeah, how you're going to install this into your PIC24? How you're going to install this into your ESP32 is not possible. All right. So therefore, in a very basic system, we just have this. You're just performing all this simple application software. This is what you always do. Those days, okay, until now, even for my assignment 1, you are doing this very simple. What is it? Anyone ask questions? Why is blinking? Okay, so then when the system become a bit more complex, okay, complex means that a lot of function, a lot of tasks being called. That's why operating system is needed on top of the microcontroller. So operating system will manage almost everything. Okay, you as a user, you just sit down here and see how he managed the system. So that's what I say. In terms of system managing, using operating system is easier than using using the conventional way of managing your system. Okay. In short, I said that using operating system is easier. Okay. So your assignment 1, you're using basic system. I can say that a lot of things you need to consider is a bit tougher. When you come to complex system, like your assignment 2, it might be a bit, I can say that it's easier. In this assignment, it's a bit easier compared to basic system. So, but of course, in future system, due to they have a lot of multi-core programming is coming in. So real-time operating system very rarely benefits the multi-core programming. That's the reason we look at it into the ESP32. Because ESP32 got 2 core, okay, dual core. So typical embedded systems solve a problem by decomposing smaller pieces called tasks that work together in an organized way. So remember, task and process is the same thing, and I use this name interchangeable. I sometimes use task, sometimes I use process. One process. Let's say what process in your assignment 1, you blink 1 LED, okay, when 1 hertz, 1 task, or you ADC, control ADC and blink the LED, or another task. So there's a multiple tasks, and all these tasks are not run concurrently. All these tasks are run at the or the system called foreground, background, or what I call that? We call it is super loop, because you got while 1 while 1, correct? Okay. Or even though whatever you are doing, your while 1 is still running, Okay, even though you use intra, your super loop is still running. Don't tell me that while one will stop running. So that like the idle task, while one is keep on running. What happened to your CPU? Your CPU is also busy, ma. Okay, so that's why when intra occur, they jump to intra. Okay, things are getting worse if your while one inside is pulling. Correct, a lot of things is running. Keep on running even though is not you're not doing anything. Okay. So system is called multitasking system, and design aspect include. So sometimes you got multitasking. When multitask run at one time. So this means that it's quite challenging because information is need to be sharing between the tasks. Let's say now what you're doing. Why in my assignment 1, I say all the tasks are individual, not sharing one another. Why I'm doing this? Because I make your life easy when you move to real-time operating system in your assignment 2. That's why you feel that if all the tasks are not communicate one another, it becomes very easy when using real-time operating system. But however, this is not true in a lot of situation. Okay, so they are interrelated one another. Okay, so synchronizing the task. This is what you call is quite challenging. Scheduling a task. Who run first? How long you run this task? Let's say, for example, you got 3 tasks. Who should run first? Okay. Let's say, for example, at home they got only one toilet. 8 o'clock, 6 o'clock in the morning. Your father wake up. Your grandfather wake up. You are waking up. All stomach ache. One toilet. Then how to synchronize the thing? That is a very question. It's the same lah. Your task is very simple. Go to the toilet, but you got 3 person. Example lah. Okay, so that's why operating system is doing this coordination. And then if you want timing to be very, very important, let's say for example, your grandfather fix. I know that grandfather every morning using a toilet 20 minutes, and your mother using a toilet 30 minutes, and your sister using a toilet, then you of fixed predicted. That's why you always use real-time operating system in this scenario. Let's have a look. Let's move on. So in the ordinary situations, we have something called a super loop. This is a very conventional type of operating system. Not operating, a conventional type of writing a program. Like this, one. Very easy. Student love it. Why? Because it's simple, ma. Student love it lah. Minimum hardware resources. What do you mean? Any microcontroller can do this. Because I don't have a special code, purposely to do super loop. So, like ESP32 can, like PIC24 can, STM can. Okay, so minimal hardware resources. Any microcontroller, and it's highly portable. Highly portable means what? I can using to Java. I can using any language. If I get to any microcontroller, also not a problem. Okay, it's not a problem at all. So that's why I put a big love down there. Student love it. Everyone love it. Okay, but when it comes to disadvantage, okay, this kind of thing is high power consumption. Why? It's not suitable for IoT devices. You keep on running, ma. When you keep on running, your CPU keep on busy. Your heartbeat you keep on busy. Cannot even put in idle mode also. Cannot put in sleep mode. How to sleep? Because you keep on running, keep on busy. So it's no good. So, but when you come to something called inaccurate timing, when I talk about inaccurate timing, 3 different very important terms is involved here. The first one is determinism. Okay, remember, super loop is not deterministic. Okay, determinism means every point of time I know what exactly is going on. Okay, every point of time, I know what exactly is going on. Okay, it's determined. Means ADC, I know that you have to, like your father or my father's morning, you know, go to toilet. I already predicted, okay, it's 15 minutes, you know, in the toilet or something like that. So first thing is the determinism. So this one, you don't know. You don't know how long, all these things, what is going on inside, you don't know. Okay, audio decoder, you know, with LCD update, USB, you don't know when something is coming in, might be a different time. It's not deterministic. Secondly, is a responsiveness. Responsiveness is how fast it responds to external event. Of course, this is it fast? If I running this first, I want something, I want some, this one need to be run, this one is taking up the resources. How can this run? This is always a lowest priority here. Let's say I run until here, suddenly, you know, ADC read need to be activated, but you're inside here, then this one will be, of course, this one will be lose out. All right, so the responsiveness is not there when using a super loop. Then of course, if this one is pulling, keep on pulling periodically, keep on checking is not one of the disadvantage in the super loop. Okay, so before moving forward, they got something called foreground and background system. So when you got interrupt service routine, you call a foreground system. Background system is your infinite loop lah, something like this. Okay? Do while loop is a background system. Your interrupt service routine is a foreground system. So in this situation, like if you talk about responsiveness, ISR3 is more responsive than ISR2 lah. Why? Because this is already going in, correct? And so on. So foreground is more responsive than background lah, because of interrupt here. Okay, so the responsiveness. Okay. Okay, let's come back to this program. Now, I'm mixing a super loop and interrupt. I put interrupt inside, interrupt. This is a super loop plus interrupt. I still want one, but not everyone interrupt. Okay, I'm not afford to, because everything is interrupt, is all the interrupt happen at the same time. How I'm going to manage also is not a good thing. Okay, let's look at this design. Is what are the advantage of this design? So one controller can support both minimum training. Okay, of course, most of the controller can have different type of interrupt. And you just need to write the interrupt service routine. And even though you're using this interrupt service routine, not much memory is needed. But however, if you're using real-time operating system, you need to use up some memory lah, additional code you needed. Okay, definitely real-time operating system, you need to install certain kernel, you know, into your system. That's the reason you use up some memory. Okay, these are all the advantage, you know, of super loop plus interrupt. So how about determinism? So it's still difficult to ensure. Why? Because I don't know when, you know, when things will happen. Okay, so determinism is diluted because even though we are sharing, even though everything is in the interrupt, so sometimes it's not predicted. So determinism means it's diluted, means its predictability is not there. So, and here we also need to consider about priority. If I got all this is an interrupt, you have to decide, well, who is a higher priority, who should be a second priority, who should be the third priority. Okay, so okay, so this means that determinism is diluted, difficult to ensure each operation will meet this deadline lah. Of course, we don't know if some interrupt take up more time, then how again, you know, is another problem. You know, some interrupt take up more time. You know, and if you are a good programmer, your interrupt switch routine should be very short. Should be as short as possible. But however, most of you your interrupt service routine very long one. You know, when longer your interrupt service routine means is the determinism is diluted even more. Okay, so When real-time operating system is coming in, different story lah. Okay, when I have a real-time operating system in the middle, okay, actually each program have one. Each section have one. Each section is running. Okay, by using something in the middle operating system called kernel or scheduler, it will decide everything for you. Which one should run first, which one should go first, which one should activate first. So real time means that it's a correct time, correct function. So we say something that, like for example, I predict, I already expected this have to happen in this within this 2 seconds, okay, or within that particular time. Okay, so and when we talk about operating system means we already got hardware and software like just now. Of hardware and software is work together. When you combine RTOS means that hardware and software manager can help us to ensure to having a correct time. Okay, it's a correct timing is it will be achieved. Okay, so why we need operating system? This is a very difficult question. But I can say that when things become very complex, then we need operating system. We'll answer this question later. Okay, operating system, basically some terms you need to understand. Okay, and you know that when they talk about embedded program, means it's a collection of firmware. And when this firmware is executed, it's called a process or task. So you always see process and task in a lot of operating system reference book. Okay, so when process is created, all these things, you know, is also created for each process or each task. So this means that, let's say, what you call that is task control block. We will come to this later, don't worry. So each task have one task control block. The task control block contain all this information. It's just like when interrupt is triggered, your program counter will push into stack, your memory accumulator A, accumulator B, all these things push in the stack, and tentatively is being stored. Okay, so each task got a special unique space for all these things. Okay, okay, like come back to the operating system lah. You still remember your operating system? Like my computer, when I press Control, Alternate, Delete, see how many tasks are running? Tasks, process a task. How many tasks are running? Okay. See, mine got 4 core. My computer got 4 core, and I'm really utilize all these things. Okay. So, who manage all these things? That's another question. I will answer all this later. Okay. Okay. So remember, do you know that? Okay, where is it? Whenever any task is switching, any driver is switching, he will he will use up a lot of memory movement. But if your memory is limited, they are using your secondary storage, which is hard disk, as a memory movement. This can be shown over. You can control this in your PC. You can disable this. Okay, what you call that? Page file and swap files .sys. Actually, is everything is in the C drive. You know, you go to the C drive. You can't see anything here. You go to view. Where is it? Where is it? I can't see. My eye is no good. Why so small? Option. Okay, change option folder and view. Then you can show all the protected file. I click this, yes, and apply. You can see that this file and the swap file. Can you see? Okay. You see, when a lot of tasks is moving one another, there will space is being allocated by these 2 files. Driver, all these things are these 2. You consume your file, you know, it help you to do system movement. Okay, but of course, if you got enough memory, okay, it might not use up these two beautiful files, but normally they will use up lah, because there's so many things here, so many things run at one time in my PC, crazy, you know. You also don't know what are they sometimes. Okay, so we come back to our. Okay, let's move on. So of course, okay, ARB just now. So again, I said that each task got their very unique space to store their information. Okay, why? Because when you come to operating system, each task while one, let's say your LED 1 Hz, while one your ADC, while one your switch, the switch. Okay, you got 3 tasks. Is it 3 tasks? You got 3 tasks there. So these 3 tasks are running while one, and how they run is managed by who? Managed by the kernel. We come to this later. So multitasking means a lot of tasks are running at the same time, but actually they are not running at the same time. Okay, it looks like it's running at the same time. Okay, although it's a multitask, unless you got so many core, like I got 4 core. So by 4 core, I can have 4 different things running at the same time. But if you got single core like PIC24, when you say multitasking, it doesn't mean that all these 4 tasks are running at the same time. Like just now, in your assignment 3 tasks not running at the same time. Okay, so basically they are switching one another. Okay, I hope that you learn for 3E student, you learn all these things from Dr. Lian Chow from computer architecture. I don't know whether you learn all this or not. Okay, so let's say they got each task. Let's say each task, they'll give him something called time slice. Let's have an example. You will come to this later. Don't worry. I will repeat all this. Okay. Let's say while one, task 1. While 1, task 2. While 1, task 3. They are not running at the same time, but however, task 1, task 2, task 3, they are running like this. They're switching task 2, they're switching task 3, they're coming back here, Example. So each task get a time slice, they call time slice. When you come into here, it's called context switching. So at certain time you are busy here, automatically they will switch into task 2. Let task 1 busy first, then automatically I switch to task 3, switch back. Okay, and this will go on and on and on. Okay. But why multitasking is something that is very difficult? Because of these 4 reasons. Each task, the speed is different. How do I know? You are faster, he is slower, he is faster, he is slower. Very difficult to manage. Another thing is a periodic. Periodic means this one I keep on repeat, need to run for 5 times, then I only give you the result. This I run for 10 times, I give you results. So it's not easy. It's periodic. And concurrent tasks. So I only can run if that is running together with me and give me some information. So concurrent tasks, the task is probably running at the same time, although it's not the same time lah. So it's it's quite complex. Is there some complex task means the task is very tedious. A lot of loop, a lot of pointing, all these things is involved inside that particular task. Okay, so that's why this will lead to the complexity in multitasking. Okay. Before looking at multitasking, let's look at the process sequence whenever you put any operating system. So in your operating system, if you use those days, do you know that those days if you're using, let's say, anyone type in your chat box, when first time you are touching the PC, what operating system you are using? Can you tell me? Windows 7, Windows XP, Windows 3.1, DOS, 98. Wow, what is Jing Hao already 98? 90. Okay, Windows 98. Okay, means you're born at 98 or 98. Okay. So because your Windows 98, when you that time, I don't think so. You're dealing with much driver, am I right? Or 98, or 98, not even 94. You know that it start with DOS first. Those days are Microsoft start with DOS. The final version of DOS is DOS 6.22. Then only he's coming down to Windows 3.1, 3.1. Then 3.11. Then only it come to the Windows 95, 97, 98, XP, and so on. So until today, things are getting more and more easy. You install, everything is given to you. But remember, for real-time operating system, when you install, you have to install according to your microcontroller, because different microcontroller have different special function register. So that's why, in order to choose a correct or a good real-time operating system, that particular real-time operating system must give you a proper board support package. So board support package is a component that provides a board hardware specific detail to operating system, so that the operating system can operate accordingly, to your microcontroller. What does it mean? Let's come back to this. Where is my stuff? Let's say MuCOS. This is a MuCOS. Miriclum is a MuCOS. Miriclum. I will copy this for you. Okay. Go here. So this Miriclum is MuCOS 2 and 3. So you see, when we go to MuCOS, I want to ensure that all these things is inside. Let's say microchip. So microchip can support PIC24. I click here. Why no line? So he said that this PIC24 only support Explorer 16 board. Okay, what is Explorer 16 board? Still remember? Yeah, I forgot to show you the lab just now. This one is an Explorer 16 board lah. Right? Explorer 16 board means that it can only support this board only. So means that when I want to install MicroCOS2, I need to do a bit of modification on this code. I can download it. Okay, so a good real-time operating system, it can allow you to support the board support package. BSP can support various of microcontroller. It's just like Windows 10 can support AMD, Apple, or I don't know, like Intel, all these things. Okay, whereas for RTOS, for free RTOS, same. It also can support a different microcontroller manufacturer like microchip. Okay. And again, like where's my PIC24? PIC24. Again, it just support Explorer 16 evaluation board. So if you want to support for your PIC24 FJ64GS002, you need to do a bit of modification. But no worry, I already do all the modification for you. You just use it. Okay. And the good things of ESP32, free RTOS already built into Arduino already. Okay, thanks to the Expressive, IDF, their development team, the Expressive work with Arduino, so they already included free RTOS into PIC24 because free RTOS is free, ma. Okay, yeah. So I hope that you know what do I mean by a board support package. Okay, let's move on. So, what are the facility in operating system? This is a general one. So, operating system can do scheduling, can do memory management, means how to free up the memory, how to clear the memory, But for information, Windows are very bad in this. Let's say if you keep your computer in hibernate mode, after some time, the memory will be garbage memory will build up. Eventually, you need to restart. Same with a lot of banks, like public bank, all these things, they need to restart their ATM machine once a month in the midnight, or else the process of allocating and deallocating allocating memory are very not well done. Okay, this is something that you should look into. Sometimes. Okay, resource allotment. Which resource to who? Like my Microsoft Word want to use mouse. Is it for Microsoft Word? And then suddenly another program also want to use the mouse. Okay, then how to resource? Synchronization. How I synchronize one another. So task 1 run first, then followed by task 3, because task 1 needs something from task 3. Task 3 needs something from task 1. So I need to synchronize one another. So OS will do all these things for you. Are you playing game? I don't know what is the most popular games nowadays. I don't know lah. So how to synchronize everything. So inter-task communication. So the tasks can be communicate one another. Time management. Okay, so keep track of time delay. Keep track of time delay. Okay, so all these things are the very important operating system. Network stack, so that you can go online, TCP/IP, all these things can support user interface. Okay, user interface are GUI lah, and driver, all these things, hardware management, so that like Windows 10, you just put in, it can play already, correct? So this, but actually, we do not need most of the things over here. Okay, like Windows 10 consume about 800 meg. Actually, if you take it out, I just need less than 100 bytes. Okay, when less than 100 bytes means it's something called microkernel. Actually, this is the anatomy of operating system, and the operating system is start from microkernel, kernel, executive, and operating system. So actually, we only need kernel. Kernel already have microkernel lah, is enough. Like Microsoft Windows 10, they won't review how they do their microkernel and kernel. This is protected. But for Linux, it's open source. You can see how it managed. For Windows, no. I attended their conference, big conference, 3 years ago in Shanghai. So I said, hey, can you share some of your microkernel things? The Microsoft, they don't share all this information. Okay, so I will go more details on all this microkernel and kernel. Okay, so class, one more thing before we go. How many of you can make it like this Friday morning again? We continue our ESP32. I'm not forcing lah, because ESP32 is optional. Okay, and because this Thursday, 4 o'clock is our tutorial. So if you guys okay, then we can play something. Those who are having problem. Oh, you got another practical. Okay, not Friday, Thursday. Our class, our practical class, 9 a.m. Okay, ESP32. Is it okay? No, class is optional. If you think that you're okay with ESP32, it's perfect, all right. Because I just continue, like what we have left out in ESP32. Those are not familiarized. I hope that you can, like last week, you don't have this, don't have that. I'm not sure you already got your component or not. Okay, sleeping time, then you sleep lah, each one. Okay, I don't force you. Okay, so those who class can leave now. I put a pool here. I just want to see. Okay. I just want to see the number. It's optional. I'm using the remaining. You still remember, I still got a lot of notes in my ESP32. Let's say 9:30 lah. Then you say sleep lah. It doesn't matter. You say no. It's not optional. It's optional. Yeah. I don't put no lah. Fundamental. Okay. Fundamental only good. I didn't say good. I just continue what is left behind, in our ESP32. Okay. Because I will just repeat some of the thing that we know. Some of you are not didn't have the board that day. Okay. And for information, ESP32 you can learn it by yourself as well because it's not difficult at all. Everything is there. And for information, I just touched ESP32 last year. Okay, or probably you guys are better than me. Okay, because previous year I'm dealing with ESP8266. But when I moved to ESP32, I found that wow, so many things inside. Wow, so many libraries inside. Wow, it's quite straightforward. Okay, anyway, 9:30 lah, optional. So I'm not forcing. Then you say I'm force you guys. Okay. And please reminded the due date of the assignment. I hope if you got any problem to let me know. Okay, those who got class, you may leave now because you got class. And those who got questions, you may stay back. Some of you got a lot of questions to ask. Am I right?